Not since the days of the Roman baths have so many people enjoyed the comfort and luxury of indoor pools, whirlpools, spas, and hot tubs as we do today. But these recreational retreats have some drawbacks in the area of comfort and operating costs. As we've all experienced, indoor pools are notorious for being uncomfortably humid. And high humidity can cause a lot of structural damage. To limit the damage and maintain a more comfortable pool environment, pool areas have traditionally been vented. That, however, drives the operating costs straight up, as you constantly have to replenish the pool with water, heat that water, and heat the pool environment. To counteract the problems of high energy costs and controlled humidity, the Dry-O-Tron dehumidifier and water heater was developed. The principle behind the Dry-O-Tron's success is simple and effective. The Dry-O-Tron recycles heat lost from evaporation and dehumidifies without the need for make-up air, saving from 60 to 80% of the energy used by conventional systems. To understand specifically how the Dry-O-Tron works, one must understand the medium by which it works: humidity. Humidity, which is in the air we breathe, is present everywhere, as it is water in a gaseous state. Water moisture is present in all material, be it a solid, liquid, or gas, in all environmental conditions, even the desert. However, as temperature rises, so too does the water level in the air. This water vapor is known as relative humidity. As relative humidity increases, it disperses or moves to cooler areas. If a wall or window surface is proportionately cooler, the water vapor will condense back into a liquid, thus promoting decay and corrosion. But with the Dry-O-Tron, humidity can be controlled. Damage, as a result, can be greatly reduced. Let's look for a moment at how the Dry-O-Tron works. Air from the pool enclosure is drawn through a dehumidifier coil, where it is cooled by a refrigerant gas to about 50 degrees Fahrenheit. When the air is cooled below its dew point, both water and heat are released. The heat energy is transferred to the refrigerant gas. Approximately 13.8 BTUs per pound of air is transferred. This breaks out to 8.5 BTUs of latent heat and 5.3 BTUs of sensible heat. As the refrigerant gas passes through a compressor, pressure is increased, and its temperature is raised by the electrical energy used to run the compressor to about 120 degrees. The refrigerant gas next passes through a pool heater where cool pool water, approximately 68 degrees, is drawn in and is heated to about 82 degrees by a portion, 8.5 BTUs, of the heat from the refrigerant gas. The refrigerant gas, in a cooler state, and now partially condensed, moves to an air reheat coil, where it heats the dry cooled air from 50 degrees to approximately 89 degrees, and fully condenses back into a liquid. The dry heated air moves out into the pool enclosure, where it picks up humidity and energy. The humid air is then drawn back into the dehumidifier coil. It again meets the refrigerant that had been cooled in the air reheat coil and is now once again a gas, after passing through an expansion valve. The complete Dry-O-Tron loop system then starts again. Now that we've seen how air, water, refrigerant gas, and energy move through the Dry-O-Tron, we can see that the energy-saving dehumidifier is a precision instrument. As such, air and water must be allowed to circulate properly and in the right quantities. Half the air must go through the dehumidifier coil, half through the bypass. If too much air goes through the coil, not enough moisture is taken out. If too little air passes through the dehumidifier coil, suction pressure drops. The compressor has to work too hard, and the dehumidifier coil may freeze up. The air going through the bypass is needed for the air reheat coil. If the air reheat coil doesn't get the right amount of air, it will have to reject its heat to the pool water instead, causing overheating. If the air reheat coil gets too much air, it will have to reject heat, and not enough will be left to heat the pool water. Exactly the right amount of pool water must flow through the Dry-O-Tron. The pool water heater performs a balancing act because it doesn't really know how much heat the pool water needs, so it has to continually readjust its output by 2 water flow valves. As soon as enough heat has been supplied to the pool water, the heat is then used to reheat the air supplied to the enclosure. When the Dry-O-Tron is first installed, unless it's summer, supplementary space heat will be needed. This is because the Dry-O-Tron borrows heat from the air around it to heat the pool water. To sum up, the Dry-O-Tron reduces humidity and structural damage. To do this, the installer must therefore provide a balanced supply of water and air to ensure proper operation. Dry-O-Tron, for the ultimate pool environment.